Correct?
Potentially explosive.
Yeah. Okay. Any Let me share my screen. Of course, it's always helpful if you can switch the screen on if your bandwidth allows or your setting allows. If not, it's all right. I just love to have a interactive session. How do I share? Here's my screen sharing. Okay. Let me know if the screen is visible. No, no, this is not the screen. I want to share. I want to share my screen. Okay. We good to go, right? So, okay,
I was recording like the kind that you had done last time.
yeah, I'm recording it.
Okay.
Yeah, I'm recording it, and also just now this time I can see. So now a show of hands as to how many of you attended last session, because I just want to understand where do I if there is someone who just has absolutely zero clue of what we discussed last time. So a show of hands of people who attended it. Okay, I see only one, two. So most of you are new. Okay, three. Sorry, I have a bad cough. Okay, all right. Let's get started. So, last time I probably started a bit fast. I went to conditional probability a little too soon. And the request was to kind of cover some of the very basics, and I'll cover some of the basics. I am assuming that you understand what probability really means. Is that understood? Probability, or is there someone who does not understand what probability really means, or the formula to arrive at it? If that is the case, then I'll probably start with that.
What are the chances of occurrence something is right or wrong, or like the chances basically you have to consider.
Okay.
The probability of occurrence we say usually, and
Okay. So it's a very simple formula. The formula is you take the total possible outcomes, and what is the favorable outcomes that you want, right? So favorable outcome divided by total outcomes. If I use a simple example of a toss of a coin. So when we toss a coin, then it is total number of outcomes are head and tail. And let's assume that we want to say head, then that is one of those. So it becomes 1/2, right? Assuming that the coin is a fair coin and everything, it's not a Sholay coin. There is likewise there is you roll a dice, and you can get one, you can get two, you can get three, you can get six. So total number of outcomes when you roll a die is basically six. And if you want any of the numbers, then equally likely, and you get 1/6 for all of them, and this is known as equally likely, right? In the sense that all are equally, all have the same probability of happening, right? Likewise, if I were to say that chances of raining tomorrow, chances of it rains tomorrow, let's say I am saying it's 0.8, right? Or 80%. So sorry. Then the chances that it does not rain, which is the complement of this, is going to be 0.2, right? Because the probability have to add up to 1. So if you see this here, 1/6 into 6 times is 1. So probability will add up to 1. And 1/2 into 2 times will add up to 1, right? So probability will always have to add up to 1. And this is 20%. And this is roughly what probability is, right? Now, typically what happens is there are something called dependent and independent events. So for example, I say you have, okay, let me first discuss independent events, right? If any of you is a doctor, I'm sorry, I give you a competition in handwriting this time. So what am I writing? Independent event. So you have independent event basically means that if one event happens, then it does not change the outcome for the second event at all, right? What do I mean by that? For example, if I say that you have uh, two dice, right? And you roll them, and I'm saying the first one gets a 3 and second one gets a 5. Then does the outcome of 5, the second roll, depend on the outcome of first one? It does not, right? That is an independent event. So probability of this getting a 3 is 1/6 on the first one, and the probability of getting a 5 on the second one is also 1/6. We saw that, right? Everyone is clear why it is 1/6 and 1/6, right? So the probability that you get a 3 on the first roll and the probability that you get the 5 on the second roll is nothing but 1/6 into 1/6, which is 1/36. And if you make a table of all the possible outcomes, you will get 1, 1, 1, 2, like this, 1, 6, like go on all the way to 6, 1, and 6, 6. Somewhere you will have a 3, 5, right? You will also have a 5, 3, but we are not saying the first roll is 5 and second roll is 3. We are not saying that. It's different. Please understand, right? So these will be 36 outcomes. These are 36 outcomes. Sorry? Is there a question? Pawan, do you mind going on mute? So if you see, the total number of outcomes are 36, right? 1, 1, 1, 2, 1, 3, 1, 6 till 6, 6. They are 36. And 3, 5 happens only once. So it is 1/36, right? And that is now P of A, the first event was getting a 3 on the first one. And P of B, the second event, is getting a 5 on the second one. And P of A and intersection B is equal to P of A into P of B. What it means is that probability that on the first roll you get a 3 and the second roll you get a 5 is equal to the probabilities, their individual probabilities, if they're independent events. If they're dependent events, the formula changes, and we'll come to that. That is what we were tackling in the last class, but many of you had questions that they were not very sure what it really meant. Sorry. Are you clear about this part so far? Any questions so far? All right. So far everything looks good, and sorry. Now we'll take an example wherein we have event A is, let's say, we are dealing with a deck of cards. So event A is, let's say, a heart, and event B is ace, right? So I am saying, if I draw a heart, does it really make a difference whether that card is an ace or not? Does it make a difference on the outcome of this thing, whether it's an ace or not? it's a heart, right? These are independent, seemingly independent events. So what's the chance? So in a deck, those of who are not gamblers like I am, for a deck there are 52 cards, right? And if you have an ace, what are the chances that you can? Sorry, if you have a heart, if you draw a heart, what are the chances that you can, or what's the probability of drawing a heart? Any guesses?
It's 1/13.
1 by 13, absolutely. And it is the reason it is 1 by 13 is because there are 13 hearts, 13 spades, 13 clubs, right? So you draw a heart, you're drawing only one card. So you're drawing one, number of favorable outcomes is one, and total number of this thing is actually a little bit different. It is this 1 by 13 comes from 4 by 52, right? You get so probability of this is sorry, it is, I'm sorry. It's not 1 by 13, it's a heart, not an ace. So you have this is wrong, this is wrong, this is 52 cards, and you have 13 out of 52, so it is 1 by 4, right? You get 13 cards, and total number of favorable cards are 52, and favorable cards are 13. So 13 upon 52 is 1 by 4, right? But what's the probability? So this is the probability of drawing a heart. What's the probability of drawing an ace? What's the probability of drawing an ace?
4 by 52.
Sorry?
4 by 52.
Absolutely. 4 by 52, and that is equal to 1 by 13. We just reverse the thing, right? So shows you I'm a very bad gambler. So now I'm saying P of heart is 1 by 4 and P of ace is 1 by 13. And I'm saying what are the chances sorry, what are the chances that you can draw a card which is an ace of heart? And that is nothing but they are both independent events. So you get 1 by 4 into 1 by 13, and you get 1 by 52 again. And there is only one ace of heart in the entire deck, right? So it is every card has is equally likely to be drawn, and so you have 1 by 52 anyway, right? So you know the answer is correct. So far so good. Did you understand the concept that I'm driving with the independence of events?
Sorry, I'm breaking your flow. I understood till the ace part. Can you just explain this one? Probability of ace, and I didn't understand the other probability. 1 is to 4 into 1 is to 13.
I want the probability of drawing an ace
And heart?
of hearts.
Ace of hearts. Okay.
Right? So which is nothing but probability of the card being an ace and it being a heart.
And the heart, yeah.
Right?
So that
is equal to, because they both are independent events, it is equal to ace is the probability of ace is 1 by 4 into 1 by 13. We established that for two independent events,
correct.
P of A intersection B is equal to P of A into P of B, right? We established that, right? So 1 by 4 into 1 by 13 is equal to 1 by 52. Correct?
Got it.
Okay. So now with this one, I will now go into what is the last time we were discussing the dependence of event. This sound is gonna sound very bad in the video. So on the dependent events, now what are the dependent events, right? Dependent events basically come when we are discussing it's going to rain, right? Then will you go out? Will you step out? That is the probability, right? So in dependent events, let's consider that you have a box. And in this box, you have three orange balls and probably, I don't know. Since I'm a man, I'm colorblind by default, and two blue balls, right? Mm. So now my question to you is, you are allowed to draw two balls from it, one after another, without replacement, right? So that is very important, that you can draw from it without replacement. And I will point to a caveat about it shortly. So I'm saying draw two balls, one after the other, right? One after the other. These are very important things, right? One after the other. Let's assume that all the balls are equally likely to be drawn out, right? So what is the probability of any one ball getting drawn out? Let's establish some facts here. What is the probability of any one ball getting drawn?
1 by 5.
1 by 5. Absolutely. That's the probability that any one ball can be drawn, right? Now I'm saying, what is the probability that an orange ball can be drawn if you are just drawing one ball?
1 by
1 by 5 again, because
1 by
Sorry?
1 by
1 by 3.
ball because put the condition now. You want an orange ball.
3 by 3.
Awesome. Who said it? Right.
4 by.
Total number of balls are 5, and you can draw any three of them for them to be orange, right? Any one of those. Likewise, what's the probability? Sorry, go ahead.
How would you guys say?
So
It will be only orange ball you want to draw.
no. So here is the thing, right? Okay. Let me explain this in a little bit more detail. All the balls are equally likely to be drawn, right? So
Yeah.
each one has a probability of 1 by 5,
Right.
right? How many balls do you have here to start with?
5.
5. So total number of outcomes, the definition of probability is favorable outcomes by total outcomes, right?
Yeah.
So total outcomes is how many?
5.
5. And out of those 5, does it matter to you which orange ball you draw? You can draw any one of these three, right?
Yeah.
Is that correct?
Okay.
And
But in this scenario, it would have been total outcome B3.
sorry.
In which condition
Mhm.
will total outcomes automatically become 3?
In two ways. One, that the total number of balls are 3, right? That is one. The other is conditional probability, which will reach. In that case, it becomes 3 actually, and we will reach there. Don't worry.
I'm doing conditional probability.
Yeah. Okay. So so you can draw any one of these three, and the total number of favorable outcomes are essentially 3, right? So that is why it's 3 by 5. Is this clear now? All right. I believe that question was asked by Rashri, so I'm hoping she got this. All right. So what's the probability of drawing a blue ball?
2
1 by 5.
2 by 5.
2 by 5 it is. Also remember, I told you that there are only two kinds of balls available, blue and orange. So remember that the total probability is always 1. So you could have answered this in another way, that if it is not an orange, it's going to be blue. So it's 1 minus 3 by 5, which is also equal to 2 by 5. So it can be arrived in 2 ways. This answer could have been arrived in 2 ways, because 3 by 5 plus 2 by 5 is 1. Clear about this part?
I just want to understand why this 1 minus 3 by 5, I mean, that way we have to show, because there are 2 balls. So can we directly just come to that 2 by 5?
Yeah, we can directly come to 2 by 5. This becomes a very important principle in solving certain class of for this thing, and that's why I wanted to just bring it to your attention, that this is one way to solve it also.
Okay.
And we will actually see that in one of the questions that we will be attempting.
Okay.
So so this is 2 by 5 now. Where was I? Okay. So now I'm saying that you have to draw two balls and without replacement. This is very important. I said this is very important. Without replacement, meaning once you have drawn a ball, you cannot put it back into the box, right? So I'm saying, what is the chance that you draw a orange and a blue ball, right? What is the chance you draw a orange and a blue ball? Anyone? How do we start with
Five.
that?
5 by 5.
Sorry,
5 by 5 1.
5 by 5. How? Please explain me. How did you arrive at 5 by 5?
All
Because there are 5 balls altogether, including blue and orange.
Okay.
So if you have to draw any 2 balls,
Mm-hmm.
therefore the number would be 5 and there are total number of balls are 5. So 5 by 5.
Okay. That basically means that basically let's understand the consequence of that statement, right? So you are saying the probability of drawing that is 5 by 5, which basically makes it 1, and that what you're saying is that I could have drawn an orange and an orange or a blue and a blue, but that those are impossible events because you are getting one orange and one blue anyway. Is this what you mean?
Yeah. Is it 6 by 10? 3 by 5.
Is it what?
Because I'll explain why. I just
No, first, one second. Let me first write down the answer here and then you can explain. What did you
3
say?
by 5.
3 by 5.
3
Okay.
by
Okay. All right.
So how I am explaining? So first case 1, where I am picking the orange ball first. So it is 3 by 5. Then I will pick the balanced ball, maybe blue ball. So the number of ball left is 4. So multiply by 2 by 4. 3 by 5 multiplied by 2 by 4 plus then the another case. So wherein I pick up the blue ball first. So 2 by 5 into then 3 by 4 and the orange ball second.
Okay.
Then add this two.
Okay. So you are very close. I mean, you are absolutely very, very close.
I'll try.
Go ahead.
One thing
Go ahead.
we are just a second. One thing I just so we are picking 2 balls at a time.
No, we are taking it one after other because if we take 2 balls at a time, then there is no question of replacement, right?
Okay.
So we are taking means we are finding this probability for picking 1 ball for that or picking 2 balls 1 by 1, but 2
2
balls.
balls. Yes.
Right?
Yes.
Okay, then that
So,
it will not be 1.
so 4 by 5?
Sorry.
4 by 5?
4 by 5. Okay. Explain me how
Okay.
did you arrive at that?
See, by doing this simple calculation, if you do 1 by, one another, the first probability should be we can pick it up all those orange balls. And the next option would be after, I'm sorry, I'm confused.
No problem. Okay. I think Tosif wanted to try, right? Tosif, what
Yeah. So what I think.
what is your answer first? What is your answer, and then we'll try to see.
First I'll take orange. So
Okay.
1 ball. So 3C1. Then I'll take blue one plus 2C1 divided by total this total balls, right? 2 balls I'm taking. So 5C2
Okay. 5C2
divided by 5C2.
divided by 5C2. Okay. Okay. You are getting into the choose notation that probably some others may not understand. So I'm not going. Excuse me. So let us do one thing, right? Let me just I will answer this in 2 different ways, and then tell me whether it makes sense to you. Okay, because I want to make sure that this is intuitive for you and you understand. This is the beginning of conditional probability, right? So I just want to make sure that you understand what I'm trying to say. Okay. So let's assume that you have right. Where is the here? let's create a table. So this is blue first, right? Okay, so this is this entire thing is blue first. Okay, and this is orange first. Okay, and create another table which says this is sorry, this is blue second, right? So this is blue second, and then you have orange second. Okay, now let's create this one. So the blue first is the is when we are making it, so you get 2 1. Do you understand what I'm doing here? This is I've numbered the balls as in blue this is 1, this is 2, in orange this is 1, this is 2, this is 3. Okay, so when I'm doing this, 3 1 goes, 4 1 goes, and 5 1 goes. Okay, then 1 2 goes, 2 2 is again blank because you cannot have the same ones. It cannot be numbers same as together. 3 2, 4 2, 5 2. Likewise, and then you draw a line here. This is done, and now you come to this part where it is 1 3, 2 3. There is no 3 3. All the diagonals will be basically non-existing. 4 3. And I'm so sorry. This is 1 3, 2 3, 1 3, 2 3, 4 3, and 5 3. And then you have the 1 4 like this, and then you have 1 5. So complete this. And now you have to pick up the balls. You have to see how many combinations give you the values that we are getting. We'll just come back to this diagram in just a bit. Okay. Now I will explain it in the probability manner. We'll come back to this diagram. So now I'm saying my condition is P of orange and blue. Is this correct? Is this what I wanted? Okay. And P of orange and blue is nothing but P of orange into P of blue having picked orange. Is my definition correct? Do you understand what I'm trying to say here with my definition? That I am saying that if I have picked up the orange ball, then I should pick up blue after having picked up orange. I must pick up blue after picking orange. Is the terminology understood over here? Or any questions in this terminology? This is very important terminology. This is the starting of conditional probability. What I'm saying is, first of all, these are dependent events. The dependent events mean if an event has occurred, then I have changed the probability of the second event, right? Of the other event. How does it happen? I have picked up an orange, right? Now that I have picked up an orange, does my probability of blue getting picked up get changed or not? Yes or no? Just a yes or no.
Before that, can you please explain this table once again? What you have done actually?
I will come to it. Don't bother too much about it. I mean, this is more important. I'll come to that table, but that is honestly, I'll just explain this. But let me just explain this part. This is more important. This is the visual proof of what I'm saying is correct, actually. So, this understanding the definition is more important. Here, I'll explain that part also. So, now my question to you is, in this example, when we were drawing a heart and an ace, did drawing a heart change the probability that the ace is drawn? Yes or no?
No.
No. Here, drawing an orange ball, does it change the probability of getting blue drawn?
Yes.
Yes. How does it change it?
Because you've taken one orange ball
We have
Because
taken-
the total number of balls will also change.
Absolutely, because the total number of outcomes and the favorable number of while the favorable number of outcomes remain the same, the total number of outcomes change, right? From 5 it gets down to 4. Correct?
Yes.
Correct? So, what is the probability that an orange ball is drawn? How much did we know? We knew it was 3 by 5, right? The probability of an orange ball being drawn is 3 by 5 into the probability that blue ball is drawn, knowing that the first ball drawn was orange. Knowing that the first ball drawn was orange, my total number of outcomes is reduced to how many? Total number of outcomes.
4.
Okay. And how many of them are the probable events?
2.
Not probable, the favorable line, sorry.
2.
2. So 3 by 5 into 2 by 4. Okay. And this is basically 3 by 10. Now, someone had asked me a question, when can be the total number of favorable outcomes itself become 3 or 4 somewhere in some case that we were discussing, right? And this is where we see that the total number of outcomes has reduced from 5 to 4. Does that answer your question? Now, using conditional probability? I do not know whether it was, who was it? I don't recall. Someone had asked me that question. I believe that, there are too many questions or there are too many, feel free to ask me the questions first. I'll wait for some questions.
Just want to understand this equation one more time.
Okay.
Like what we have done here is like 3 by 5 into 2 by 4 is because there are 3 orange balls, that's why it's 3, and there are total outcome is 5. And for orange, maximum favorable outcome will be 3. That's why it's 3 by 5.
Yes.
And 2 by 4 is if we draw one ball out of 5, the total outcome will be 4 only.
Yeah.
Because we are drawing one ball.
So let's assume
and
that
then-
this ball is gone.
Okay, this ball is gone, correct. That's why there are 4 remaining. That's why now it is only 2 blue balls are there. So that's why 2 by 4 has come.
Yes.
That's it.
And now the probability of drawing a blue ball is basically 1 by 2 because there are 2 out of 4.
1 by 2. Correct.
Another thing is that if we are saying without replacement, then this equation fits, right? Because we're not putting any more balls.
Yes. That's
But if we'll put more balls, then
no,
the
not if
equation will-
we replace it, then they become independent events.
Yeah.
So this one can be written, or this one can happen in a different way also, if it's so that it,
I know where you're going with it. I know. Yeah. So,
yeah,
so let me tell you this.
Yeah.
I was
PB into P O by B, that will also be similar like that.
so let's say that you basically ultimately what you wanted was an orange and a blue ball, right? You did not say I want first orange and second blue. You did not say that. What you said was we want an orange and a blue ball, right? Okay.
Right.
So now, now the thing with conditional probabilities, and this is very, very important, is that so just give me a second here. I'm just checking something. I'm just checking something mentally, okay? Because these things confuse me sometimes. Okay, so P of blue and then P of orange given blue. We could have gone about this way also, right?
Exactly.
So what is
Yeah.
what is the probability of drawing a blue ball? 2 by 5.
So it will be 2 by 5.
2 by 5.
2 by 5 into what is the probability of drawing an orange after the blue has been drawn?
It's 3 by 4.
3 by 4.
And we have come to the same I mean different ways, but we have come to the same numbers,
Yeah, that I'm saying. That I was saying that it can be done on that.
right? So the beauty of this is, and this is where conditional probability and so you in your regular tests you might get some similar questions on conditional probability like this, but in your main exam, if Professor Shovan is handling it, I don't know about the other professors, then you're going to get some complicated questions, and this is the stepping stone into that. So as per this, P of A and B, A and B are two different events, right? P of A and B is equal to P of A given B into P of B And this is also equal to, as we have just seen, P of B given A into P of A. Right? So these two terms are equal basically. Any questions so far on this one? Okay. So now having the difference is, now I have established what is independence of events. In independence of events, P of A intersection B is simply equal to, these formulas are very important, is simply equal to P of A into P of B. And for dependent events, you can pick whichever you want, but what is important is to understand that it is, let's assume I'm picking P of A here, then it is P of A into P of B given A. Okay. First P of the any event, and then the probability of the other event, knowing the first event has occurred, A has occurred, right? What is important to know here is, because this was the formula, actually is, this is the actual formula. In case of independent events, okay, can someone tell me what is an independent event in terms of probability now?
Yeah, which doesn't affect on each other.
Yeah. Yes. Which does-
Independent.
Exactly. So if A is independent of B and B is independent of A, if one is independent of the other, then the other is by definition independent of the first one. So if A is independent of B, then basically what it's saying is P of B given A is equal to P of B, which is what? This is for dependent events. The formula is valid for independent also, except the fact that A does not affect B, and that is why the formula becomes P of B. Basically, P of B given A becomes P of B, or P of A given B is equal to P of A. That's all. A little bit heavy, or is it still okay? Any questions here? Yeah, go ahead, Arish. You have a question?
I was trying to give you a thumbs up, but I got the I understood. Thank you.
So,
Thanks for that.
So, Anup, just one question here. These formulas, I mean, the book which has been given, like from there also we can get this, or like we are noting down. But is there any specific thing that we can refer specifically related to probability formulas?
quickly checking if these are there in your book or not. Just give me a second here. I think the formulas are definitely there. They might not be there. I just saw it. Ouch. I just saw it might not be, the explanation might not be in such detail.
Yeah.
Right? The formulas are definitely there, but you might not, the intuitive explanation might not be there in such detail. Okay. Okay. So we are done with this part. Now, there is something called, people often confuse between independent events and mutually exclusive events, right? What is a mutually exclusive event? So mutually exclusive event is essentially, if an event A happens, then it guarantees that B will not happen, and vice versa, right? So, sorry.
Just a question, Anup. Will it have three variables? It will affect the entire.
Will it have what?
If we have let's say if it is not orange, blue, let's add a yellow color one. So it will add a difference in the conditional probability.
It will always. It will. Conditional probability goes actually just the entire thing goes into. There's a huge formula which you will not require it honestly in MBA, but in artificial intelligence we use it a lot. So yes, there is too much.
Okay.
Yeah. So and I will see some flavor of that. We'll see in some of the problems that we'll tackle in the coming sessions, probably even today. Okay. So now mutually exclusive basically means, let's say I'm rolling a die, right? So if 2 occurs, can say 4 occur on the same die,
On the
It
same
cannot.
dice, no.
right? It cannot in that event. So that's a mutually exclusive event. Now, for mutually exclusive event, what happens is, let's say, okay, and you should always get a feel for the Venn diagram, right? So when 2 events are independent, not mutually exclusive, right? When 2 events are independent, then what I had said was P of A and B. This is A intersection B is equal to P of A into P of B. Sorry. Okay, these are for independent events, right? For exclusive events, we'll switch to OR. Now, P of A union OR. P of A union OR typically has the formula of P of A plus P of B. So this is say A, this is B, and I'm saying I want P of A. So what formula we'll have to use is, I want all this region, then I'm doing A union B, right? So I want all this region, and there is a region that I've calculated twice. Is that correct? This region,
Yes.
this region I have calculated twice, right? So I need to subtract at least once, not at least once, I have to subtract once from it, right? And this region is A intersection B. Okay. If they are mutually exclusive, right? If one says that the other cannot happen, then what will be the value of P intersection B?
PA minus PP.
If I'm saying that
It will be zero.
it will be 0. There is no P of A intersection B in case of mutually exclusive events, right? This is a general formula, and this holds true except that when they're mutually exclusive, when one says the other cannot happen, then there is no intersection, right? If A is saying B cannot happen if I'm happening, then this region becomes 0, right? Any questions?
So basically, mutually intersection events, they also have got no dependency on each other. This is what we are saying.
No.
Like-
No.
Not.
Okay. Independence basically says that if you happen, I don't bother. I don't care anything about it. You might happen, but I am my own self, right? Mutually exclusive basically is very different, right? If you happen, then I cease to exist. That's very different, right? So earlier, so basically you have to make sure that there are 2 different. Okay, can someone now help me with the original formula for this one? This is P of A intersection B. What is the original formula for this one? The actual formula?
So P your into P of the given A.
B given A. Right? Only in the case of, so please understand, the actual formulas are this and this. In mutually exclusive, this becomes 0, and in independent events, this becomes P of B. I'm emphasizing this point again and again because this is where you are likely to make mistake. So feel free to ask the questions. Simple questions also. Feel free to ask the questions. We'll probably use another 20-25 minutes to solve some problems now. But are we clear here?
I have understood the independent situation, right? Where A and B are independent of each other. There is no dependency. The other situation which you have written, right, where there is a subset of A and B, what is that situation then?
Which
if there is mutual exclusivity, it will become zero. But what will be the situation where there is like little dependence also? So can you give me some other example in this?
mutually exclusive. If the child is a girl, then the child cannot be a boy. Right?
Right.
Okay. So mutually exclusive comes as a even a coin toss. I mean anything. So basically, if you have landed at 2, then the 5 is out of question. So these are mutually exclusive ones. A fact that the probability that in real life, okay, the probability that you have picked up an offer from, say, a company like Accenture basically means you will not sign the offer from some other company, right? Correct? These are mutually exclusive events. Does that make it better?
Yeah.
Okay. So these are mutually exclusive events, right? You do not, you will come across some mutually exclusive events, and we'll see them as we hit them. Okay. So in the last session, it's a good thing that only 3 of you were present. Let's work on some of the problems so to understand. This is what we tried to solve in the last one. Okay, so a very simple problem to start with. If you have seen the video that I uploaded, you probably would know the answer. But anyway, give it a try. I hope you can read the font size is sufficient, or do you want me to zoom in? In an experiment involving smoke detectors, an alarm was set off at a college dormitory at 3 a.m. Out of 216 residents of the dormitory, 128 slept through the alarm. Okay, so first of all, total outcomes. How many? That's the first thing you should note, right? And I hope you are you have a pen and paper and all those things just to
216.
right. Now let's go to the other part. 128 slept through the alarm, right? So 128 slept through the alarm means slept folks basically are the happiest slots. So 128. If one of the residents is randomly chosen, what is the probability that this person did not sleep through the alarm? So what is the probability that this person did not sleep through the alarm? So this person did not sleep through the alarm. How many did not sleep through the alarm? Can we calculate that?
88.
88. So 216 minus 128. So 88 did not sleep through. Is it 88 or it is 88 or 78? I do not know, but you check. Okay, yeah, probably 88. You're right. So 88 did not sleep through the alarm. So what is the favorable outcomes divided by total outcome?
88 divided by 216.
Clear to everyone that this is how you will calculate the probability? Yeah. Okay. Now, the organization that employs Jacobi is organizing a parent-daughter dinner for those employees having at least one daughter. This is a good question, actually. Each of these employees is asked to attend along with one of his or her daughters. If Jacobi is known to have 2 children, what is the conditional probability that they are both girls, given that Jacobi is invited to dinner? Assume that the sample space is given by girl, 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 boy, boy, girl, boy, boy. And all of these outcomes are equally likely. Where are the outcomes? Okay, anyway. So first go read the question once so that you understand what is being asked, and then we'll attack this question. Make sure that, and then I would like for someone to try this question. Any guesses?
One by 3.
1 by 3 is absolutely correct. How did you get to that?
Yeah. So basically, the requirement is that Jacobi, so at least three daughters it is mentioned. So once it is completely boy, so that is the reason I have taken sample space as a three.
Yeah.
And at least one daughter. So one event by three.
Okay. So we will. This is a very interesting question because this is a conditional probability question. So P of two girls given is invited. Did I convert the question mathematically correct? Do you follow how I converted this into a probability conditional probability question? Let me know.
Can you please explain again? Because how it is came to two girls?
The question is, if Jacobi is known to have two children, so there are two children, right? What is the
Okay,
condition?
assuming two children are daughter.
No, what is the question is this? What is the conditional probability that they are both girls? They are both girls. They are both girls, given that Jacobi is
Okay.
invited to the dinner, right? And what is the condition to get invited into the dinner?
You should have at least one daughter.
At least one daughter. So does this qualify?
Yeah.
Does this qualify?
Yeah.
Yes.
Does this qualify?
Yes.
Yes. Not.
Will Jacobi be invited if
Last one is not.
No.
okay? So now, did I convert the problem correctly? Probability of two girls, Jacobi having two girls, given that he is invited. So, given that he is invited, what is the total number of outcomes in which he will be invited?
There are three outcomes.
Three outcomes.
Three outcomes, right? And in which how many are favorable outcomes?
One.
One. In the next session, I will actually take you through another way to solve this problem, but I don't want to introduce that because it will make it right away. But do you understand the intuition behind solving a conditional probability question? This guy goes out of the favorable outcomes, total outcomes immediately because there is a conditional probability clause. Remember the shrinking from 5 balls to 4 balls? Right? The box where we had, so that is the same thing that is happening here. Your search space is shrinking, and so you are reduced with 1 less and 1 by 3. Is everyone clear about how did we arrive at this answer?
Yes.
Okay. No. Now, suppose that two people are randomly chosen from a group of 4 women and 6 men. What is the probability that both are women?
4/10.
4 by 10. Okay. How do you want to tell me how?
Total number of outcome is 10 because there are the sample sizes 4 women and 6 men. But there are 4 women, so 2 women can be only from this group, and therefore 4/10.
Anyone else? While I'm just writing.
It's like 2 by 10.
1 by 5.
Okay, some answers.
So, can you use that concept here? Like two are taken, so 4C2 divided by
Exactly. That is what is. I'm introducing you to that concept right now, so that others can also understand. Right. So, okay. If you do not understand what 4 choose 2 is, or 5 choose 2, or n choose 2, n choose r. I'll just explain that concept to you. So, what is the probability that both are women, right? So, in how many ways okay, what is the total number of outcomes, right? In how many ways can you choose the first person? Total number of outcomes. How many ways can you choose the first person?
Total outcomes are 10.
That is the total number of outcomes, right? Okay. And now, in how many ways can you choose a woman from them? First one. No, forget this question. I'm just picking one person. And we said that we could have chosen one person from all these in 10 different ways, right? I could have chosen M1, M2, M3, M4, M5, M6, and W1, W2, W3, W4, anyone. So that is the total number of outcomes. What's the what's the favorable outcome?
4/10.
Sorry,
4/10.
4. Favorable outcome is 4, right? I could have chosen W1, W2, W3, W4. Now, this basically is my first woman. I want one more, right? So now, how many are reduced? What is the set reduced to? 9,
9.
right? And how many for favorable outcomes?
3/10.
Okay. So now, this is 1/3 and this becomes 4/30. Okay. And there is a formula basically which says, please pay attention to this one, because if you get a little bit of, I am sure you will not get it, but you should be aware of it, because it comes in very, very handy, especially solving the problems very fast. It's called NCR, basically N choose R. Okay. The formula for this is, and it's very simple. It's, deceptively simple formula. Don't get at all boggled by this, what I'm writing here. What it says is factorial. I hope everyone knows what a factorial is, right? So a factorial is, if the factorial of a number is basically that number multiplied by all the numbers down to 1. That is what a factorial is, right? So factorial n is basically n into n minus 1 into n minus 2 into n, forget the brackets and everything, I'm not taking care of that. Okay. And divided by, likewise, I will not expand it. I'll just simplify it to you with an example. So let's say I'm going with 4C2. Why I'm going with an example, you will understand right away. So I will write factorial 4 divided by, can someone walk me through the formula, please? So that someone who is not familiar with it. Factorial. Put in factorial R. What is R? 2. And what is n minus R? 2. Okay. So 4 into 3 into, can I say factorial 2? Yes or no?
Yes.
Divided by factorial 2 into factorial 2. And this factorial gets done with, and you remain with 4 into 3 by 2 into 1. So see the formula, how simple it is. You just have to use the digits up to the number that is there. So 4, let's take some other example very quickly, so that if you're not familiar with it, you will become familiar with it by the end of today. I will choose 8C5. Okay. And this becomes, till where should I write? 8 into how much? 8 into, just be with me. This is the beauty of this is very, very good. I should actually go ahead and write it till where? How many numbers should be there on the top?
6 into 5.
In something like that, right? But just look at that. I will just say factorial 5. Why will I say factorial 5? Because I know that there is a factorial 5 here, and I know that there is a factorial 8 minus 5, which is factorial 3. This is factorial 3. Okay. So factorial 5 and factorial 5 go. So it becomes 8 into 7 into 6 divided by 3 into 2 into 1. And I mean, 3 into 2 goes into 6, so it's just 8 into 7. Are you just following what I'm saying here? Or no?
So it was clear till before this step, but this is
Okay.
I'm finding it confusing.
Okay. The reason why, and you will see at least 2 or 3 questions in your book on this one. That's why. Okay. So NCR basically, N choose R is basically in how many ways can you choose R things from N things? That is what it means. I can choose 2 women from a group of so many in so many ways. That is where this is coming from. Okay. Choose basically stands for choose. Actual choose, English choose, right?
Okay.
So now I said do not bother about the formula because it's deceptively simple. Why? Because I said let's say 6C1, and someone will say that okay, I will have to write factorial 6 divided by factorial 1 into factorial 6 minus 1. This is equal to 6 into factorial 5. Just please say okay if you are with me. Factorial 1 is 1 anyway because it is 1, and 6 minus 1 is factorial 5, so they both cancel off, and the value is just 6. And in the question is, in how many ways can you choose one person from a group of 6 people? And the answer is 6.
6.
Okay. Now I will show 6C5, and this is where the beauty of factorial lies. You don't have to really do too much of mathematics. This is factorial 6 divided by factorial 5 into 6 minus 1 factorial 1. The formula reverses itself, right? This is the same formula. And the value is still 6.
Yeah.
Right? So what I'm saying here is, you just have to expand the top series by the number that is over here, or 6 minus this, whichever is lowest. Either you expand this 5 till 6 into 5 into 4 into 3 into 1, or just one, the difference between them, whichever is lower, just expand that much and you're good. And now you will get this with some practice. But what Tausif was arriving at here, because where is this sheet, the question here, why this is important is because of, so I made this, I'll keep this mental model of M1, M2, M3, and W1, W2, W3. So in how many ways can you choose 2 people from a group of 10 people? That's my question first. The total outcome. This is the total outcome. Total outcome is in the denominator. And is my framing correct? In how many ways I can choose 2 people from a group of 10 people? That's the total outcome. Is that correct?
Yes.
And
yes.
And what's the formula for that?
So it's like 2NR. I mean N
10C2. 10C2. In how many ways you can choose 2 people from 10 people? 10 choose 2. Okay, this actually there is a case, but this does not go greater than this, right? R never goes more than n, right? So in 10 choose 2 ways, I can choose 2 people out of this. And in what are the favorable outcomes? I have to choose 2 people, 2 women from how many? How many women are there?
There are total 4 women.
So 4 choose 2.
Yeah.
Okay. Now 4 choose 2 is basically, I'll help you, just make sure that you follow along. 4 into 3 divided by 2 into 1. Okay. This is because of the formula. Likewise, 10 into 10 into 9 divided by 2 into 1. And this 2 into 1 and this 2 into 1 cancels. And this becomes 4 into 3 divided by 10 into 9. 3 times, and you get 4 by 30. Is that the answer we had got, by doing the previous method?
Yeah, the same answer we got.
Right? So this will come with some practice, but if you just practice it probably for 2 days, you will understand the concept between choose to. Okay, I'll not spend any more time on this because I really want to wrap it up in the next 5-10 minutes. Let's. What is the probability that one is a woman and the other is a man? Anyone? What is the probability that one is a woman and the other is a man? So P of A intersection B. Did we do this kind of problem previously? This is same as probability of A into P of A given B. Sorry, B given A. Yes. Did we see this formula previously?
Yes, we have.
And we can do it in the counting ways also. I will, if you guys are feeling a little bit overwhelmed with this, try to. I have already shared this sheet. I can share it again. The questions at least. Try to attempt at least this B part of the problem, and so that if you do not get it in the next session when we discuss it, it will at least help you. Just this part, okay? And this is a very, very nice question. This is one of my favorite questions. Okay, so and I think I will just solve. Probably I'll solve this one and this one, and then we'll stop. Just two more questions, and then we'll stop. But let me just take a pause here. Any questions so far, or any clarifications? Yeah, go ahead.
Do we have any books where we can at least revise these concepts? Although I've understood it. Any book which would be very simple.
I have shared a book. Unfortunately, it's not a simple book. I will try to find if there is a simpler book. But my only request would be do not go to class 12th book or class 10th book because you will just get lost in the entire thing. If you have questions, feel free to ask me the questions. I'll help you because again, as I'm trying to make some videos. I'm trying to study for my MTech and all those things. So that's okay. But I will, the book that I've shared with you already has fantastic examples which give you very good. Unfortunately, it is a little. It deals with some very simple examples, but it goes very, very rough, very fast. And I can share some questions with you separately. That's a different thing. But I'm just thinking, I'm sorry, I do not know any of the books that are very, very simple that you will. So feel free to ask me questions. I'm happy to answer your questions. Okay. As I said, I'll take a pause and ask for any, any questions so far or any concept that you have not. If you do not understand some concept, we can do that instead of solving this question right now. So we can do that. Let me know. Otherwise, I'll just go ahead and solve these two questions.
So, sir, in exam, we'll get this level of question, or these are very much complicated?
No. You will not get the thing that you are going to get are going to be a little bit more complicated than this one. But if you understand the base of this, then that complexity is completely removed. I'm actually driving you towards a conditional probability and then into Bayes theorem. And the questions you are going to get will be from Bayes theorem. And trust me, you will be scratching your head just to understand the question. Okay, I mean, take my word on it. Again, I don't know about other professors. Professor Shovan, if you have applied your mind to the conditional probability, it becomes exceptionally simple. I mean, the formulas look very, very tough, but the concept becomes exceptionally simple and you can answer the question. We saw that with this one, right? We saw that with this example, what it really means to remove the sample space. And my idea is, typically what happens is you don't get the practice time, and I'm giving you with that practice time here, honestly. As I said, some of these questions you might get in your the quizzes that keep on happening. You might not, I'm not sure. But in exam, you will get conditional probability, you will get Bayes theorem for sure. Okay, shall I proceed with this one? Because this talks about something which we just learned. Or do you want to take a break, or you want to? I mean, do it in the next class, or do you want to continue with these two examples?
So we will finish these two examples, and then
Cool.
in next class we will see something
Yeah, cool.
more complex.
Cool. Okay, it won't get more complex. I mean, that's the whole point. It will get into Bayes theorem, which is anyway. Okay, let me not blabber. So suppose we roll a pair of fair dice. So each of the 36 possible outcomes. Do we understand why there are 36 possible outcomes? Does everyone understand that? Let A denote the event that the first die lands on 3, and B be the event that some of the dice is 8. Okay. So what is P of A? First event. Anyone?
1/6.
P of A is 1/6. Does everyone understand why it is 1/6?
Only one time 3 will come out of 6 times. 6 sample space.
Sorry, can you repeat that? What did you say? Only?
So one die has 6 outcomes. So total outcomes are 6.
Mhm.
But we need 3 as a favorable event. So that is the reason it will occur only once. So that is
No. That no. That is not. Your answer, it is 1/6 is correct, but that's not the reasoning. Anyone else? Do you know why P of A is 1/6? Okay. Can you tell me all the possible outcomes?
36.
1, 1, 1, 2, 1, 6. I will skip 2. I will go to 3, 1, 3, 2, 3, 6, and I will skip the remaining. I will go to 6, 1, and 6, 6. So these are 66 events. 66 outside.
6/36 actually.
So it's 6/36 because three on the first die basically happens 6 times, and this is 6/36. That's why it is 1/6. Everyone understands this part? P of A, this part. Let P of B be the event. The sum of dice is 8. Okay, so now it is saying that sum of dice is P of B is the sum of dice is basically 8. And so now out of this, 8 happens when you get 2, 6, you get 3, 5, you get 4, 4, you get basically 4,
5, 3, 6, 2.
3, and 6, 2. So how many times does B event happen?
5 5/36.
Okay. And P of C is when the sum of the dice is 7. So P of C is you have I'll write here 1, 6, 2, 5, 3, 4, then 4, 3, then 5, 2, and 6, 1. 1, 2, 3, 4.
1/6. That is.
So 1/6 again, right? 6/36. So it is 1/6, correct? So we have established P of A is equal to this, P of B is equal to this. Now it is saying P of are A and B independent. How do we know that they are independent, or how do we check for independence? What is the formula for checking independence?
A intersection B is equal to A event of A into event of B. PA into P.
P of A into
P of B.
P of B, right? And what is P of A? What is P of, okay, now P of A intersection B. So first of all, P of A is what? That the first die lands on 3. That is A. Okay. And what is P of B? That the sum of the dice is 8. So now I wrote down here 3, 1, 3, 2, 3, 3, 3, 4, 3, 5, 3, 6. In how many cases is it true that the first die lands on 3 and the sum of the dice is 8? What is that configuration here? 3, 5?
Yes.
So P of A intersection B is actually 1/36. Is that correct? that there is only one particular candidate that solves this. The favorable outcome is only 1 out of 36. Is this clear?
Yes.
Okay. Now, P of A is how much? From here, 1 by 6?
1 by 6.
1 by 6. And P of B is how much?
5 by 36.
5 by 36. And is this 1 by 6 into 5 by 36, is it equal to 1 by 36?
No. No.
So are they independent?
No. No.
Okay. Now, are A and C independent? So P of A and C. A and C is basically, thank you. So sum of the dice is 8. 8 is now sum of the dice is 7. That is C event, and that happens with which one? 3, 4, right? And that happens also once, so it is 1 by 36.
No,
And
3.
Sorry.
No.
Go ahead.
C.
Yes. A is basically the event that the first die lands on 3.
Yeah.
So it can be only 3, 4.
Or from 3, 4, 3.
No, not 4, 3, because that is not A intersection C.
Oh, okay. So in that case, that is only 1 by
36, right? And what is P
Yeah.
of A?
A, that is 1 by 6, and yeah, that is independent.
And P of C is how much? 1 by 6. So is 1 by 6 into 1 by 6 equal to 1 by 36?
Yes.
So A and C are independent. And now this will boggle you. Why is a die roll independent when the sum is 7 and not independent when the sum is 8? I will not go ahead with the next question. I'll wind up with this intuitive answer, and that is the essence of conditional probability. The reason is, what are independent events? By definition, what are independent events?
It does not affect each other. I mean,
Does
independent in nature.
Yes, right.
Mutually exclusive.
No, please. Mutually exclusive is basically they are dependent on each other. We discussed that. Mutually exclusive, right? So now I will write it down completely for you because it is important. 1, 1, 1, 2, 1, 3. Just be with me, please. 1, 4, 1, 5, and 1, 6. Oh, I'm sorry, this is horrible. Okay, never mind. I hope you understand the intuition behind it. This is 6, 6. I'll try my best. When the sum is, can you go on mute, please? Deepak. So when the sum is 8, okay, the sum 3, 1, 3, 2, 3, 3, 3, 4, 3, 5, and 3, 6. When the sum is 8, then do you get to reach it using if the die lands on 1? Do you get to reach the sum of 8 when the die lands on 1?
No, it's not possible.
Right?
Yeah.
If you land on 1, then you are guaranteed to reach 7, but not 8. The fact that it has landed on 3 has reduced. It's a conditional probability that first die landed on 3 has removed this entire set from itself. Did you understand the intuition behind why 7 is independent but 8 is not? 7 says I am within the grasp of 1, 2, 3, 4, 5, 6. right? And no matter what the first die lands on, I don't care. Can 8 make the same claim? No. 8 cannot make the same claim. 8 says I can only be reached if the first die is not, if one of the dies, I mean, forget first die, but I mean, but yeah, let's, because we are talking about first event here. The first die does not land itself on 1. That's a, if the first die lands on 1, there is no way I can be reached. So, do you get a sense of what independence here means? I mean, or how independence as a concept is very different mathematically and intuitively that we do not understand from the simpler definitions that we have seen so far. Does it give you a flavor of that independence? Any thoughts? Anything? Any open to question? Feel free to ask me the questions on this one.
It means what is the first value that we get on the dice determines if we are going to get the outcome of 8 or not. So if it's 1, we will definitely not get the outcome as 8. If it's 2, then there are probably chances of getting the outcome as 8. When we do the second dice, it may be 6. So 6 plus 2 kind of.
Yes.
I mean, this is how we are trying to understand.
Yes. What it is saying is, yes, and again, let me repeat the intuitive words.
Mhm.
The C is the event of getting 8, right? So C is saying, getting a 7. So C is saying, irrespective of the value of A, my probability does not get changed. Right? Independence is basically one event does not alter the probability of the other event. And
Yes.
C is saying that no matter what A gets, what A lands on, my probability remains the same. Okay, I'll actually probably, if there's a chance in the 4th or 5th session, I will take you through one more example which is very counterintuitive. And I will lay it to you for now that if you get, if you have a, let's assume that there's a couple and they get a girl. Right? Now, what's the probability that the next child will be a girl? 1 by 2. Right? The probability that you have a girl, a child who is a girl now is not your child would be a girl or a boy will be 1 by 2 irrespective of what you have, right? But there's a counterintuitive example that given the first child is a girl, what is the probability that you will get a girl now? And that changes the answer, just like what we saw in GG, BG, and GB. Because given the first probability is a girl, then my favorable outcomes or my total outcomes completely change now. So it's very counterintuitive. I hope you got a taste of it, because we are going to build upon that. And this will be this. And I really don't want to spend more than 2 or 3 sessions on conditional probability and Bayes theorem, because random variables and all those things are pretty they are you're going to get some questions from that also. I mean, you're going to get questions from everywhere, but I want to make sure that you understand and you can apply yourselves to solve the questions in the exam paper. So that is that. I think I'll stop with that. Feel free to ask me any questions, or it helps me if you give the feedback or you ask me the questions beforehand so that I can prepare. But sorry, those of you who attended this the first session, I hope this was better than the first session in terms of the theoretical treatment of it.
No, thank you so much. This is really helping us out to understand the concepts and what exactly we can expect in the exam. Also, that is something we are getting an idea of what sort of. I mean, probably a little harder than that. Also, this also, but yeah, this is a good base.
Sure.
Thank you. If
All
we
right.
have doubts while solving any problems, can we reach out to you for our workings?
You can just ping me. You can ping me on the group if you want. You can ping me independently. I have thankfully I have lots of free time presently, so I can answer that. I can take care of any questions you might have. That's all right.
Okay. That would be really good. Thank you. Thank you so much.
All right, no worries.
Thank you
All
very
right,
much.
all right. Have a good night.
Thank you, Anand.
All right. See ya. Bye. Why is it not just
Just want to